Hello. In this session, we are going to discuss one topic in the course Structural Simulation Laboratory. The topic is stress analysis of a cantilever beam. Myself, K. Manoj Kumar, Assistant Professor, Department of Aeronautical Engineering, Hindustan College of Engineering and Technology. First, I am selecting the static structural. Either I can drag it from here or double click it. I am naming it as beam. You can save the directory wherever you want to save. If you see here means engineering data is already ticked. That means some material is already assigned. If you want to change the material means double click it here. You see here means structural steel is already selected. If you want to change the material means you go here, select the engineering data sources. In the first table, it will show all the material: composite, non-linear, additive manufacturing material, piezoelectric material, fluid materials. Okay, whatever you want, you can select it. Now I am selecting the general materials. If you click this one means another table appears here. Okay, we are going to analyze the stress analysis of cantilever beam. So I am going to select the structural steel. For selecting, you need to click this add icon. If you click this means a bookmark icon will appear here. It shows it is added to the directory. But here the structural steel is already selected, so we have this icon. Next, close it. Go for geometry. If you double click it means design modeler will open. In design modeler, first we need to select the units. Here I am changing it to millimeter. Next I am selecting the plane. I am selecting XY plane. After that I am clicking this option. Look at the face option. If you select this means it will change like this. After that I am going into sketching. In sketching I am selecting the line. I am clicking on it the origin. If you see the H icon there, it shows horizontal line. After drawing the line, I am going into dimensions. In dimensions, I am clicking general. Okay, if I click the line means, okay, here it shows 90.139. Now I am changing it to 300 mm. After selecting it, again I am clicking this option. Then I am generating it. Okay, next I am going into concept. If you see here means it shows 0.0 bodies. Next I am going into concept. I am selecting the lines from sketches. Again I am going here, clicking the sketch 1. It's selected now. Applied, and I am generating it. Now it shows one part one body. That means we convert the line into part. Again I am selecting the sketch. I'm going into concept and selecting the cross section. Here we can select whatever cross section you want, but here I am selecting the rectangular cross section. Okay, we have a rectangular cross section, dimension shown here. For breadth I am giving 30 mm and height I am giving 15 mm. Okay, then I am generating it. Now it's generated. Okay, then if you see, click here means in the line body. If you click it again means the cross section not selected. Here you need to click it and select the rectangular cross section and generate it. Okay, so for the design part is over. Next we need to move to the modeling. If you see here means engineering data is completed, geometry also completed. Now I am selecting the model by double clicking it. If you see here means geometry import, geometry materials cross section coordinate system are completed without any error. Next is mesh. I am simply generating mesh, automatic mesh. Okay. You see the message, I am satisfying with this mesh. If you want to change the element size means you can go here and change it. Okay. Next, static structural. I am clicking the fixed support. Okay. No, this is a cantilever beam. So I am fixing it, applied. Fixed support is applied here. Okay. And I am giving a load force at this end. Okay. I applied it. Here the vector I am changing into component. Okay. I am giving the load in Z direction, downward direction. Okay. I applied it and then I am going into solution. I need a total deformation. I'm also bending moment required. Shear force also required. Now I am solving it. The result is completed. If you see the total deformation, bending moment and shear force, you can save the result. Thank you.